Assalamualaikum and hi. Cleaners or detergents and sanitizers are commonly supplied as concentrated liquids. This will reduce the chemical storage size, but you need to know how to dilute them. In this video, I will explain some formula that can be used in dilution of the chemical, cleaning chemical and sanitizing chemical. Your supplier of detergent and sanitizer should provide product info and safety data sheet, also simply called SDS. And in this document, you will get information on composition in percentage of the chemical. The important composition that you should note is the active ingredients. In product info document, there is brief description of use instruction, which basically will give the range in percentage for dilution and the temperature of application. Chemical concentration in cleaners and sanitizers are given in percent solutions, but it is important to note that which type of percent solution that the document are referring to. They are weight per volume percent, and weight percent. Weight per volume percent means weight of solute, which you can use units of gram or kilogram per total volume of the solution. This unit you can use milliliter or liters. Okay, where solute means soluble compounds that dissolve in solvent to form a solution. In food industry, solvent for cleaner and sanitizer dilution is mostly water. Volume per volume percent means volume of solute per total volume, then times by 100. And then weight percent means weight of solute per total solution, per weight of the total solution, and then times by the 100. This is an example of chemical label with weight percent concentration. Okay, as shown here, 50% weight indicate 50 gram of sodium hydroxide per 100 gram of solution, which consists 50 gram of sodium hydroxide plus 50 gram water. Or in other words, we can explain by this: 50 gram of sodium hydroxide is present for every 100 gram of solution. All right. So now let's look this example, okay, how we can use the percent solution in order to dilute the cleaning chemical that we needed. Okay, so in this example, the question asks you to calculate how many grams of sodium hydroxide are required to prepare 500 ml of 2.5% weight per volume solution of sodium hydroxide. Okay, so first we should first let's redefine the percent solution. So 2.5% volume per volume solution of NaOH. This means 2.5 gram of sodium hydroxide over is present in every 100 ml of solution of the chemical. So then now we need to calculate the weight final, the weight final ataupun or the weight need, that one we need. So per 500 ml. Alright. So basically, this is we set a proportion to calculate the weight needed, the weight of chemical needed. Alright. So rearrange the equation. Okay. So 2.5 gram NaOH divide by 100 ml and then times by 500 ml. What you will get is 12.5 gram of of the solution, the chemical that you need. Okay, okay. So this is it. So now let's look the next example where it using volume per volume percent. So the question is, how would you prepare 700 ml of 50% volume per volume isopropanol? So let's define the concentration. This chemical have a solution percent of 50% weight per volume per volume. Okay, so volume per volume, I just using iso P to present in isopropanol. So this means that 50 ml of isopropanol divide by it present in every 100 ml of the chemical solution. So then we need to set up a proportion to calculate the volume need, the volume that we need. So in order to prepare 700 ml of solution. Okay, so then rearrange the equation. Where are we? Where is my pen? Okay, sorry. So V need is 50 ml isopropanol divided by 100 ml and then times by 700 ml. Okay, you will get 350 ml of isopropanol. Okay, the solution. So the total solution that we need to prepare 700 ml here, okay, consists of isopropanol and water as a solvent. So basically, from here, we need to add up 350 ml of water in order to get 700 ml of solution. Okay, so that's to get the final volume. Now let's look for the next example where it using weight percent solution. Okay, so here 900 gram of 15% weight hydrochloric acid solution will contain what mass of acid? Okay, so we need to find we need to define first the percent solution. Okay, 15% weight over weight of HCl hydrochloric is actually means 15 gram of HCl over is present at every 100 gram of total weight, okay, of the total weight, okay, or not total weight of the mixture, chemical mixture of solution. All right. So here we need to set up the proportion to calculate the amount needed. So amount needed is in weight. So divide by the total weight of solution that we need. Okay, 900 gram. Then we rearrange the equation to find the weight need. So and then you will get 135 gram of HCl. Okay, and then remember, this weight is actually consists of HCl and the water as the solvent, so that you need to add 135 gram HCl into 765 gram of water in order to make up 900 gram of the total solution. Okay. All right. Okay. Important to note as well, in some chemical product specification, it using sorry, in some chemical in most chemical is actually concentrated chemical, concentrated cleaners, concentrated sanitizer. Okay, this is some of information that I extract from the product info of Diverflow SU562. This is product from Diversea. Okay, so this is a name of product. Okay, now let's look on the technical information of the product. This is basically caustic detergent. Sorry. This is a caustic detergent, alkaline-based detergent for CIP. Okay, for CIP of dairy. Alright. So the active ingredient here is sodium hydroxide. This is the active ingredient. Okay, this is the active ingredient. And then important to note, the weight percent here is 2.2.3. All right, and then in the use instruction section, it has stated that it should be dilute at 70 degrees Celsius and within the range of this dilution. Okay, so how to calculate this? Basically, you have two concentration information. One is concentrated information, and other one is concentration of the dilution that you need to prepare. So for this is we call like a stock dilution, dilution, and you need to use this equation. You can use this equation. Okay, so let's look the example. So in this example, okay, dilution from concentrated detergent, okay, the question asks you to find the amount of SU562, which is the name of the detergent just now, where it contains sodium hydroxide with weight percent 22.3 that must be added to 100 liter of water in order to drop the sodium hydroxide concentration down to 2.5 weight percent. So let's look. Okay, let's write the equation of the stock dilution just now. C stock times by V volume of stock. Okay, C stand for concentration, and then is equal to C final and the volume of the final. Okay, volume of that we need. So we fill in the information, substitute the information in this equation, 2.23%. And now this is the V stock. And then 2.5% times by 200 liter. So by rearrange the equation, we can get the V stock equal to 2.5% divide by 2.3 weight percent, and then time by 200 liter that we need to prepare. So you will get 22.4 liter of Su562. Okay. Alright. So this is the chemical that you need to measure. You need to take from the concentrated. Then again, you need to add up with certain amount of water. Oops. Certain amount of water as a solvent. So this amount is basically 200 mil minus by 22.4 mil. Right, then you will get the amount of water that needed to prepare this dilution. Okay, so in other product, cleaning chemical or sanitizing chemical, the direction for use indicate like this. Okay, 3.9 milliliter over liter. This simple and easy for you to measure the dilution. Basically, you need to take up 3.9 mil of the chemical solution, and then add is 1 liter. Okay, 1 liter of the solvent. So it's simple. All right. So then, if let's say the size of the cleaning tank is 100 liters, so then you times to 3.9 mil over liter in order to get the amount of detergent needs. Okay. Okay. So now let's look for sanitizer. Common unit for sanitizer concentration is part per million. Is part per million ppm. And wait, so, and the sanitizer is specified as a percent. Okay, as a percent. Where are you? As a percent of active. Where this 1% of active represents 10,000 ppm. So, and 1 ppm is also means 1 milligram per liter. So to calculate the dilution weight needed of the sanitizer in order to dilute it in certain volume, so we are going to use this equation. Okay, this equation. So this one, W mean weight of the sanitizer, V is means volume of solution, percentage here represent the active. Active mean the active ingredient in the concentrated sanitizer, and the ppm is parts per million of actives in the final solution. Let's look the example here. Okay, how much sanitizer with 1.5% of active is needed to prepare 1000 liters of a solution of a sanitizer at 100 ppm of active. Okay, so let's write down the equation. Weight needed, okay, weight that we need to take out from this concentrated detergent in order to prepare to dilute it in 1000 liters. All right, so we need to have we need to times it to times the volume with the ppm. All right, and divide by percentage, then times by 10,000. Okay, so this ppm is referring to the parts per million of active in the concentrated sanitizer. So let's substitute the information. We have volume is 1000 liters, time by, let me put the unit, okay, time by 100 ppm, okay, and then 1.5% of active times by 10,000. Okay, 1.5% represent percentage of active in the concentrated, of sanitizer. So by solving this equation, you will get 96.66 kilogram. Okay? 6.6 kilogram of concentrated sanitizer that need to be take and then to prepare and dilute it into 1000 liters of water. Okay. So now this is a simple equation, okay, how you can, if let's say you get the concentration in volume, okay, and then but you prefer to measure in weight because it's much easy by using weighing only, so you can use this formula where V equal to weight over the specific gravity, in order to convert it, let's say from volume to weight or weight to volume. All right. Okay. The calculation for dilution is simple actually, but sometimes confusing because there are too many concentration, too many formula to represent concentration actually. All right, we have weight percent, we have volume percent, we have weight per volume percent, and in other application it represents weight per volume, there is no percentage, and there is also molar. So but the important things when you want to do when you need to calculate how much volume needed, how much weight needed in order to prepare a certain concentration of chemical which has been diluted. All right, the volume, you need to identify first the volume that needed, but this is simple for existing plant because the existing plants already been the design has been established. Okay, you already define all the size of the equipment, and then you already have one specific tank for cleaning, so you just need to know the volume of cleaner tank and the volume of sanitizer tank to substitute into your dilution formula. But for plant design where it's ongoing, okay, the plant is not yet exist, but you are in the progress in designing the plant, you need to determine the cleaning and sanitizing capacity by collecting the information of volume of each equipment, the tank size, the piping length, piping diameter, and CIP flow rate. All right, this part that is quite complicated. All right, and this part that means part which need a lot of calculation need to be done because you need to identify volume needed for every equipment that where the cleaning detergent will flow inside it. Okay, that's it for now. I hope what I'm sharing you in this video will be beneficial for you. All right, thank you and see you again. Bye.